So the intrinsic electron and hole concentrations are given by Ni equals to capital NC to the power minus of Ec minus Ei by kT, and Pi, that is the intrinsic hole concentration, equals to Nv to the power minus of Ei minus Ev by kT. Now let's find out the product of N0 and P0, and then we are going to find out the product of Ni and Pi. By putting the values of N0 and P0, what we have just now arrived, we have Nc to the power minus Ec minus Ef by kT into Nv e to the power minus of Ef minus Ev by kT, and simplifying this we have Nc into Nv e to the power minus Ec plus Ef minus Ef. So Ef cancels and we have e to the power minus Ec minus Ev whole divided by kT. As we know, that is, this is the band gap energy, that is the energy gap difference between the conduction band and the valence band. So this Ec minus Ev can be written as Eg, and hence the value is Nc in V e to the power minus of Eg by kT. Let's find out the value of Ni into Pi. So the value of Ni and Pi will be equals to Nc into Nv e to the power minus Ec minus Ei, that means minus Ec plus Ei, then minus Ei. So Ei will be cancelled here and we have e to the power minus of Ec minus Ev by kT. And again we can write Eg here in place of Ec minus Ev. So the value will be Nc into Nv e to the power minus Eg by kT. And you can find that N0 P0, that is the product of N0 P0 and the product of Ni Pi is equal. We also know that for an intrinsic semiconductor, the electron concentration, that is Ni, is actually equals to the hole concentration Pi. For an intrinsic semiconductor, we know that Ni equals to Pi. So we can write N0 P0 is equals to Ni Pi, and it can be written as Ni square. So N0 P0 is nothing but equals to the square of the intrinsic carrier concentration. And again, as Ni Pi equals to Nc Nv e to the power minus Eg by kT, and Ni equals to Pi. So Ni Pi or Ni square will be equals to this. So the value of Ni can be simplified as square root of Nc into Nv e to the power minus Eg by twice kT. So these are very important formulas and we have to keep it our mind, as because in our later part of our semiconductor physics we have to apply these relations. So keep it in your mind. Now another convenient way of expressing the values of N0 and P0 are N0 equals to Ni e to the power Ef minus Ei by kT, and P0 equals to Ni e to the power Ei minus Ef by kT. And from these equations we can interpret that if the Fermi level lies at the intrinsic energy level, then N0 will be equals to Ni, and as the Fermi level moves away from the intrinsic level towards the conduction band, then the N0 or the value of N0 will increases exponentially. And similarly, for the expression of P0, we can conclude that if the Fermi level moves away from the intrinsic energy level towards the valence band, here also the value of P0 will increases to a higher value. Now students, from these two expressions of N0 and P0, you can conclude that the values of N0 and P0 are directly proportional to the temperature capital T. But here Ni is also a function of temperature, and Fermi level, that is EF, also varies with temperature. So this is not a simple straightforward case of temperature dependency for the carrier concentrations, but it looks like a really tough one. So let's move on to the topic right now.